Hello, everyone. This is Mr. Ainsworth, and we're going to get into a little review on for the Unit 7 exam here in AP Pre-Calc, and we're going to develop a mind map here on solving trig equations with factoring involved. Okay, and believe it or not, a lot of these techniques come right from Algebra 1, so that's where we're going to start just to understand the idea, and then we're going to apply it to some trig equations here. All right, so put your title right there in the middle of your mind map here, solving equations with factoring here. And let's start off with something simple that we saw back in the olden days of Algebra 1. Okay, so suppose we're trying to solve 2x squared minus 4x equals 0. Well, this is a quadratic equation, and it's equal to 0, and you are always taught to factor here, and you factor out the GCF, which if you look at 2 and 4, the common factor is 2 between x squared and x. Well, the common factor is x. So it's possible to factor out a 2x here. And when you do, you get 2x times the quantity x minus 2 equals 0. Okay? Distribute back through and you'll see that it actually works. Okay? And then what you do is after you factor here, you set each factor equal to 0. Again, this is just Algebra 1 techniques. So when is this equal to 0? And when is x minus 2 equal to 0? And just use your common sense. 2 times 0 is 0, so you get one answer is 0. One number minus 2 is 0, and you better come up with 2. All right, so we have two solutions there, and we're solving by factoring. Okay, solving by factoring. So let's extend the idea, and let's go up here, and let's solve an equation, a trig equation. Okay, so we're going to solve for x on the interval from 0 to 2 pi. So we can limit the number of solutions here. And let's take a look at a fairly simple equation like this one here. So 2 times the tangent of x times cosine of x minus tangent of x, right, equals 0. Let's take a look at this one here. All right, and so when you solve an equation like this, you'll notice that there's a common factor, right? And guess what? That's called tangent x, right? Tan x. So you factor it out, and then you multiply it by the remaining factors, and that is 2 times cosine x minus 1. All right, distribute back through, and you'll see how it works. Okay, at this point, we're going to do the same thing as we did earlier here in the Algebra 1 example, and we set each factor equal to 0. So we have tangent x equals 0. And then the other factor, we have 2 times cosine x minus 1 equals 0. And you have to figure out when is tangent x equal to 0, and you have to understand that, guess what, tangent x is the same thing as sine of x over cosine x equals 0. And the only way for the rational function here to be equal to 0 is when the numerator equals 0, okay? That's the only way for a fraction to equal to 0. So you got to be thinking, when is sine x equal to 0? And that's when x equals 0, pi, and 2 pi. So we have three solutions there from 0 to 2 pi. Okay, next one, you're going to take this next equation here, isolate the cosine function by adding 1 first. So 2 times the cosine x equals 1. Divide that by 2, and you get cosine equals 1/2. And you have to think, cosine of what angles equal a half? Well, one of them is 60 degrees or pi thirds, right, in quadrant 1. And then in quadrant 4, where it's also positive, that's 2 pi minus that, or 5/3 pi. So quadrant 1, quadrant 4. There's two solutions here. So we have 5 solutions on this equation, guys. 5 solutions. And they're, here and here. Okay? So yeah, you're going to have to solve an equation of this type where there's some factoring involved on the exam. And that's why this mind map is a good thing to do. All right? All right, let's take a look at another one here. Let's go here. We're going to also solve for x on the same interval. So let's take a look at a different type of equation here. So 2, I'm just making these up as I go. 2 times cotangent x times sine x minus root 3 times cotangent x here is equal to 0. All right, and notice that I'm choosing equations with a common factor. That's why I started off in the beginning here with the Algebra 1 example of factoring out the GCF, right? Because that's how you handle these equations. And so you factor out the cotangent x. Okay, what do we get? Well, we get 2 times sine x minus the rad 3, and guess what? That's equal to 0. So you factor first, Okay, so let me put, I should have done this in the beginning here. You factor, that's step one. Step two, you set each factor equal to 0. And then step three, you solve. That is your three-step process in Algebra 1, and that's what you do in Trig. All right, nothing changes algebraically. You know, as you get older and more experienced, the steps don't change, guys. It's just these crazy expressions, and it just gets more complicated. Even in calculus, we do the same algebra, guys. Same thing, nothing changes. So now we set each one equal to 0. So cotangent x is equal to 0. 2 times sine x minus rad 3. That's equal to 0. And then cotangent of x equals 0. So cotangent is defined to be cosine x divided by sine x. And you got to ask yourself, when is that equal to 0? Well, it's when the numerator is equal to 0, right? As I said earlier. So you have to ask yourself, when is cosine x equal to 0? And that's at the top of the unit circle at pi halves, and that's at the bottom of the unit circle 3 pi halves. So we have two solutions there. Now on the other one here, we're going to isolate your sine function now. So add root 3 to both sides. Divide by 2. And you get sine x equals rad 3 over 2. And then you have to be thinking, okay, what angle is that? Okay, so I'm going to draw the 30, 60, 90 just to give you a visual. This was something I always do here. And the sine of 60 degrees is root 3 over 2. 60 degrees is pi thirds. So the sine of pi thirds is rad 3 over 2 using SOHCAHTOA. All right, so we got pi thirds here. So one answer in quadrant 1, okay, sine is positive in quadrant 1 is pi thirds. And the other answer is in quadrant 2, and that's pi minus that. So, and pi minus pi thirds is 2/3 pi. Okay, and there we go. So we have two more solutions. So we have 4 solutions in all. All right, we have 4 of them. All right, 2 here. So pi halves, 3 pi halves, pi thirds, 2 pi thirds. 4 solutions. All right, and let's do another one. We'll do one more here on our mind map, and then you can extend it. Go into your homework. There's problems in your homework, right, that involve things like this. I'm just making these up, but you could take, and you should do this, add to your mind map. Go search in section 7.3, because I think this is section 7.3. Actually, I'm not gonna 7.3 and something else. I think there are other. Yeah, there's 7.3, 7.5, and 7.6. You're gonna have to look at your homework and find some more equations. Okay. All right. So next one here, let's take 2 cosine x times sine x minus sine x, actually plus sine x. Let's change it up a little bit here. Is equal to 0. And again, we're solving all of these equations from 0 to 2 pi. All right. So what's your common factor? Well, in this case, it's the sine x function, right? So you want to factor it out. So take sine x, factor it out, and you get 2 cosine x plus 1 is equal to 0. So there's your factoring step. And then you set each factor equal to 0. So you got to figure out when is sine x equal to 0, and when is 2 times cosine x plus 1 equal to 0. And then over here on the left, sine is equal to 0, as you guys know, at 0, pi, and 2 pi. That's pretty straightforward. And then over here, you isolate your cosine function. So you want to subtract 1 first. So 2 cosine x equals -1. Divide by 2, and you get -1/2. Well, cosine's negative in quadrants 2 and 3. So your first solution here, if you look at the special right triangle up here in the top right of your screen right here, in your special right triangle here, the reference angle, we know that the cosine of cosine of 60 degrees, which is pi thirds, we know that's equal to 1/2. That's your quadrant 1 reference angle. Okay? But we want an angle in quadrant 2 that gives us a ratio of -1/2. Well, to get that, you got to take pi minus your reference angle. So that's going to give us 2 pi thirds. That's your quadrant 2 angle. Now to get from quadrant 1 to 3, we're going to add pi to pi thirds. There's 2 different ways to do this. This is one of them. And so we're going to take pi and add it to pi thirds to get to quadrant 3. And guess what? That's 4 pi thirds. Okay, 1 1/3 pi, that's 4 thirds pi. So we have 5 solutions here too as well. Check that out. We have 3 here, 0 pi and 2 pi, and then we have 2 thirds pi and 4 thirds pi. So we have 5 solutions. So 5 soluciones here. That's a 5 right there, guys. Okay, 5 solutions. X is equal to 0, pi, 2 pi, 2 thirds pi. I've just listed them out. And then 4 thirds pi. Look at that. And so you're going to have to get good here. And I would go look in your homework here. Look in homework sections 7.3 through 7.6, 7.3 through 7.6, and find another example and extend this mind map. I challenge you on that. Do that. You're supposed to do your homework, but then you're supposed to master and practice your homework. So go search for another one. I can guarantee you there's one in there. And then practice this really well, because guess what? This stuff's on the exam too. All right, so this is Mr. Aynesworth here. Hopefully that helped you out a little bit on solving trig equations, all right, using the basic techniques from Algebra 1 and using the idea of factoring, okay? So practice well, and I'll hope to see you in class. Take care. Bye-bye.